Dot School presents Simultaneous Equations 1. If I give you the equation x plus y is equal to 10, can you find the numerical values of x and y? You might come up and say, why not? X is equal to 6 and y is equal to 4. After all, 6 plus 4 is equal to 10. But then there are a whole bunch of other values that would also work. How about, for example, x is equal to 9, y is equal to 1. 9 plus 1 is 10. How about x is equal to 5, y is equal to 5. 5 plus 5 is 10. And when you consider decimals and negatives too, there's an infinite number of possibilities that would all work. In fact, to find x and y, we need another independent equation in x and y. Let's say x minus y is equal to 6. Now, there's only one x and one y that will fit into both of these equations. That is, x is equal to 8 and y is equal to 2. 8 plus 2 is 10 and 8 minus 2 is 6. An infinite number of answers if you look at each one of these equations, even for the second one. X and y over here can be anything as long as they maintain a difference of 6 between them. And x, of course, is the larger of the two. But if you look at both equations at the same time, there's only one solution. And the word simultaneous means at the same time. So it's about solving two equations at the same time. There are different methods to solve simultaneous equations. In this video, we are going to learn how to solve simultaneous equations by using the method of substitution. In the method of substitution, you pick one of the two equations and solve for one of the two variables in terms of the other, and then use that in the other equation. Let's try and solve these two equations using the method of substitution. I'm going to name this equation A and name this equation B. You could call them 1 and 2. Naming equations is just a way to make sure you can reference them whenever you need to. Like I said, we pick one of the two equations. I'm going to go ahead and pick equation B and solve for one variable in terms of the other. So I'm going to use equation B and solve for x, that is, find x. Obviously, you cannot find the exact numerical value of x from one equation. All you can do is you can get the y on the other side and say that, okay, if x minus y is equal to 6, that is, x is 6 more than y, we can also rewrite that as x is equal to y plus 6. And because this x in equation B and the x in equation A, they refer to the same number, we can plug in this value of x, y plus 6, into the first equation. So if I rewrite equation A with this value of x, we have x, that is y plus 6, so y plus 6, that's x, plus y is equal to 10. In this new equation we have over here, well, it's not really a new equation, it's still equation A. We just plugged in the value of x from equation B into equation A. And the good thing is, there's no x in this equation, therefore we can open up the parentheses, say that, okay, y plus 6 plus y is equal to 10, bring the y's together, 2y plus 6 is equal to 10, take the 6 on the other side, that subtract from both sides. So these two cross off, we have 2y is equal to 4, which means if you divide both sides with 2, you have y is equal to 2. Now once you have one of the two answers, you can use any of the two equations, whichever you feel like. Plug the value of y into that equation, you got 2 here, and therefore x has to be equal to 8 because only 8 plus 2 will give you 10. How about, let's say, 3x minus 2y is equal to 19 and 4x plus y is equal to 18. Let's call this equation 1 and let's call this equation 2. Now you could pick any of the two equations and solve for any of the variables. Because I see that the coefficients of x and y in the first equation as well as the coefficient of x in the second equation are different from 1, I know that if I were to solve for these three, I would get a fraction. In order to avoid a fraction, what I'm going to do is I'm going to solve for this y in terms of x in equation number 2. So basically, I'm going to take this 4x on the other side and say that, okay, from equation number 2, we have y is equal to 18 minus 4x. And then we have this, we are going to plug this value back into the first equation where we have a y here, so that this becomes, the first equation changes its form. It's only got an x now. 3x minus 2 times 18 minus 4x minus 2y, y is 18 minus 4x from the second equation, is equal to 19. There's no y here, there's only x now. So we are going to go ahead and solve for x. This means 3x, open up the 2 times 18 is 36, minus 36. 2 times 4x is 8x, but you have a negative and a negative here, that makes it a positive 8x. Is equal to 19. Bring the 3x and the 8x together, you have 11x. 11x minus 36 is equal to 19. Take the 36 on the other side, that's add 36 to both sides of the equation. So we have 11x is equal to 36 plus 19, which is 55. 11x is 55. Divide both sides with 11. Just do this. Therefore, x is equal to 5. And the moment I have x is equal to 5, I am almost done. I'm going to take this value of x and put it back, let's say in the second equation. So we have a 4 times 5, 4 times x is 5. That's 20. So 4 times 5 is 20. And 20 plus y is equal to 18. Therefore, y has to be equal to negative 2. So the values of x and y that fit into both equations 1 and 2 at the same time simultaneously is x is equal to 5 and y is equal to 2. How about another one? Let's say we have 11x minus 8y is equal to 27. Let's call that equation number 1. And then we have 3x plus 5y is equal to negative 7. Let's call that equation number 2. You are free to choose your own equation and whichever variable you feel like and solve it in terms of the other. I'm going to use equation number 1 and let's say I'm going to solve for x in terms of y. So we have this equation number 1 and I'm going to keep the 11x on one side, 11x. Take the 8y on the other side, which means it's going to be a plus 8y on the other side. 11x is equal to 27 plus 8y. And then x, remember we need to solve for x, not 11x. Divide both sides with 11. We have x is equal to 8y plus 27 or 27 plus 8y over 11. And this x is also true for the second equation because the two equations are referencing the same value of x and the same value of y. Therefore, I'm going to plug in this value of x in terms of y into the second equation. We have 3x, that is 3 times, that's x. What's x? 8y plus 27 all over 11 plus 5y is equal to negative 7. At the moment I see this denominator 11, I'm going to multiply both sides of this equation with 11. That helps me get rid of this denominator 11. So pretty much saying that, okay, all of this times 11 times 11. So when you distribute the 11 on this one and on this one, this 11 and this 11 will get crossed off. And obviously you have to do the same on the other side, times 11. So that in the next step we have 11 and 11 cross off. 3 times 8y plus 27 plus 11 times 5 is 55y is equal to negative 77 on the other side. Let's just open up this parentheses now. 3 times 8 is 24. So we have 24y plus 3 times 27 is 81 plus 55y is equal to negative 77. 24y and 55y add up to 79y. That's going to be equal to, if you take the 81 on the other side, you have negative 158. And then divide both sides with 79. We have y is equal to negative 2. Once we have the value of y, the rest is just a piece of cake. Pick up this value of y and put it back into one of the two equations. Let's say equation number 1. We have 11x minus 8y, y is negative 2, so minus 8 times negative 2 is equal to 27. I'm going to get this over here. 11x minus 8 times negative 2 is positive 16 or plus 16 is equal to 27. You take the 16 on the other side, you have 11x is equal to 27 minus 16, that is 11. Therefore, divide both sides with 11, you have x is equal to 1. So our answer is x is equal to 1 and y is equal to negative 2.